Hey guys, welcome to Chapter 16 of Holt Physics. I'm Annika, and today we're going to be covering electric forces and fields. So this chapter is divided into three main segments. We'll go over electric charge, then we'll look at electric force and the electric field. So in this segment, I'll be covering section 16.1, which is electric charge. So we're going to begin this chapter by looking at electricity, which you've probably experienced before, in a situation such as rubbing a balloon against your hair. You'll notice that your hair stands up and is sort of attracted to the balloon, which means that some charge or force must exist between them. This is known as static electricity, which is electrical charge that builds up due to rubbing contact between two unlike materials, so in this case, the balloon and your hair. Now, when things have electricity, we say that they have a charge. There are two different types of charges. The first is a positive charge, as I've drawn below. In this case, the positive part of the system would be your hair. There's also negative charge, which in this situation would be the balloon. And it's important to keep in mind with these different charges that like charges will always repel, while unlike charges will attract. This means that a positive charge would attract a negative charge but repel other positive charges. So you might have noticed in the situation with the balloon and the hair that in order for each item to gain a charge, there must have been some transfer of electric charge. So we're going to look at exactly how that works. Everything around you is made up of atoms, which have protons, neutrons, and electrons. Protons and neutrons are sort of stuck in the nucleus of the atom. They make up this central location, as you may have learned before in chemistry. However, the electrons of the atom are around the nucleus, meaning that they can move more freely between atoms. In a situation where electric charge is transferred, it means that electrons move from one atom to another, which I will draw over here. Now, since electrons are negatively charged, in a situation where some electrons move from one atom to the atom that gains electrons would have a negative charge, while the atom that loses them would have a slightly positive charge. These charged atoms are known as ions. You'll also note that in situations when electric charge is transferred, the overall charge is always conserved. This is because there will always be an equal positive and negative charge, so when you add those together, the net charge will remain zero. When changes in electric charge occur, we say that they're quantized. This means that these changes in charge occur as integer multiples of a number that we'll call E, which is equal to 1.6 times 10 to the negative 19th coulombs. We'll get to coulombs later, but C represents a coulomb, which is the unit of electrical charge. This means that if a charge is added or subtracted, it would be added by an amount of either E, or 2E, or 3E, and so on, as the amounts get larger. There are two types of material that can be involved in the transfer of electric charge. The first are conductors, which are materials in which charges can move freely. So for example, this metal rod that I've tried to draw. The other type of material is an electrical insulator. This is a material in which charges cannot move freely. So for example, this rubber eraser. The type of material affects how quickly charge can flow through it. There are a few main methods for transferring electric charge. The first is through physical contact. You saw this in the previous example, where a person rubs a balloon against their hair, transferring the charge just by touching the objects to one another. The second type of charge transfer does not involve physical contact. This is known as induction, which involves charging a conductor by bringing it near another charged object. So I've drawn this situation where a charged rod with negative, I've drawn these blue negative signs to show that, is brought near a sphere that has equally distributed positive and negative charges. Now, what would happen when the rod is brought very close to the sphere, I will redraw this situation, with these negative charges, is that it would attract the positive components of the sphere, bringing them all over to this side, while the negative are left on the opposite end of the sphere. Now, in order to charge by induction, the conductor must be grounded. This means it's connected to earth by means of a wire or pipe. So that's an important thing to keep in mind when you're studying induction. The final method for transferring charge is known as polarization. This is a very similar process to induction, in that charge is realigned without physical contact. However, it takes place in insulators, changing the surface by moving around these positive and negative components to other locations.